something like dry leaves, maybe almost no nitrogen is released. What are some considerations if you do fertilize with either manure or manure compost? One is it's a great source of micronutrients. Do make sure it's composted though. If it smells like ammonia, which most fresh manures do, it can impact germination and damage your seedlings. Do be aware of residual herbicide risks. So manure piles that have been sprayed with certain herbicides can end up impacting the next crop. Some manure products are high in salt. Those primarily are the dairy manure compost, just because of supplements that have been fed to the dairy cattle. Sometimes manure compost has weeds and pathogens, less so in compost than in fresh product. And it's very easy to over apply nutrients, especially phosphorus and potassium, as I'll show on later slides. That can cause a nutrient imbalance. You can also contaminate water either by runoff or by leaching. So here I show a table of how much N, P, and K is removed annually by a typical vegetable garden. And I'm asking this kind of as a multiple choice question with just two possible answers. The first is, do you think that 1 inch of manure would supply somewhere around 20 times more nitrogen than your vegetables need, maybe 30 times as much phosphorus, and maybe about 15 times as much potassium? Or do you think 1 inch of manure would provide 6, 1, and 6, meaning maybe about 2 years of nitrogen, 2 years of phosphorus, and 2 years of potassium? And the answer is that 1 inch of manure will supply somewhere on the order of 20 to 30 times as much nutrients as your vegetables need in a year. And so if you are applying manure or manure compost, you don't need to add it every year. You maybe only need to add, say, a quarter or a half an inch, maybe every few years. To add about 5 pounds of nitrogen per 1,000 square feet, which will meet the demand of most vegetables, takes somewhere around 500 pounds of manure compost, which works out to be somewhere around 11 tons per acre. From a gardening perspective, more like 500 pounds, so about a quarter of a ton of manure compost over a pretty large garden, 1,000 square feet. In general, we gardeners tend to apply probably too much manure and compost. Something else that's important to think about is what's called the nitrogen to phosphorus ratio. So if you can match the nitrogen to phosphorus uptake of your plants with what you're adding, then neither nitrogen nor phosphorus will accumulate. So again, I show an annual vegetable harvest, how much N, P, and K is removed. And then the last column over here is the nitrogen to phosphorus ratio. So it'd be great if you could find an amendment that roughly matches that. Manure compost has a somewhat lower N to P ratio, 3 to 1. What that means is it has a higher amount of phosphorus than you actually need. And so if you add manure compost every year, you're probably going to accumulate phosphorus. Yard compost is a little bit the other way, 7 to 1. So you might be adding maybe not quite enough phosphorus. And then green or food compost is 1.6 to 1. What that means is that you're going to really, to apply enough to meet your plant's nitrogen needs, you're going to apply far too much phosphorus and really start accumulating phosphorus in your garden. So what products or what amendments do have 5 to 1 ratios? Well, it turns out fall leaves have about a 5 to 1 ratio. And green pine needles. I don't prefer them because they're waxy, but they do happen to match that 5 to 1 ratio. So what happens if you only slightly exceed your vegetables' nitrogen needs with manure. This is a graph that shows after about 15 or 16 years of just slightly accumulating nitrogen, you will greatly accumulate phosphorus. And in fact, this diamond here indicates at what point you have sufficient phosphorus. So only after 3 years will you have sufficient phosphorus. After that, you have more than you need. Potassium really will increase if you add manure or manure compost. And somewhere around 8 or 9 years, you have plenty. And beyond that, you have excess. There was a study down here of 67 Midwest gardens where the researchers supplied a pile of composted dairy manure. They didn't educate the gardeners about, over application. They just supplied it to see what would happen. Well, what they found was that 92% of those gardens had excess phosphorus and 88% had excess potassium after just 1 to 6 years of adding composted dairy manure. So it's very easy to over apply. I want to back up again and say organic matter is great, but just like with anything, too much of a good thing is not necessarily a good thing. So the question would be, well, how can you increase nitrogen and soil organic matter without adding too much phosphorus and potassium? Well, what you want to find is an organic amendment besides manure or manure compost that's higher in carbon and maybe a little bit lower in phosphorus and potassium. And that would be products like dry leaves or wood shavings, straw, or peat moss. I would recommend adding organic matter based on your crop's phosphorus needs, and then add nitrogen separately. Don't try to supply all of your nitrogen with manure compost or you'll have way too much phosphorus and potassium. So there's other ways to get nitrogen into your soil, either a chemical fertilizer, an organic fertilizer such as blood meal, or maybe planting legumes or a legume cover crop. Something else that might be useful, a lot of times in the Bozeman to Belgrade area, we have soils that are pretty fine, meaning a lot of clay and a lot of silt. And so sometimes you might just need to add sand to kind of make more of a loam soil rather than just a silty soil. So just summarizing that little bit on organic material, as fresh material decomposes in the soil, it releases nutrients pretty quickly. The remainder becomes compost or humus in the soil, and eventually becomes this magical term, soil organic matter. If you want to know about how much nitrogen gets released from soil organic matter, we know from research done here at MSU that if you have a soil with 3% organic matter, it's going to release somewhere around 1.6 pounds of nitrogen per 1,000 square feet. Now that's probably 1/2 to 1/3 of what a typical vegetable garden needs. So just your organic matter is going to release quite a bit of nitrogen. If you have 6% or 9%, then you can multiply that 1.6 and you might be able to meet all of your crops' end needs with just organic matter. The structural material compost, the more stable part of it, will last longer. And that's what really provides structure to the soil, as well as increasing water holding capacity. And again, it's hard to supply nitrogen with compost. So consider high-end fertilizers or high-end amendments, and therefore you won't over-apply phosphorus or potassium. So another multiple choice question for you. When using legumes to supply nitrogen, which is true, 1, legumes fix very little of their own N if soil N is sufficient. 2, legume seeds must be inoculated annually before planting. 3, the rhizobia that help legumes fix nitrogen are not legume specific. And 4, soil critters not used to legumes get digestive upset. And the answer would be 1. If there's lots of nitrogen there, those little nodules on the legume roots, say pea or bean, won't fix very much of their nitrogen. The second point here, legume seeds must be inoculated annually before planting. What happens is if you've added an inoculant in a previous year, those rhizobia, those bacteria stick around for several years, and so you probably don't have to inoculate every year. And most of the time, these rhizobia are legume specific. So the rhizobia that works for pea and lentil, for example, does not work for something like, say, chickpea or bean. Another question for you is which bean plant is or was actively fixing nitrogen? You can probably tell by this nice dark green leaf and these nice big nodules that this is the plant that was actively fixing nitrogen. These yellow leaves are classic sign of nitrogen deficiency, and notice that there's almost no nodules on this bean root system. Any questions? I do see a question over in the chat. I know Emily said we might wait till the end, but I think I can answer it pretty quickly. What kind of sand can be used? So you can buy anything from like a sandblasting sand, which is very coarse, to more like a kid's play sand, which you'll see is mainly coarse, but there's often some fines within that. And either of those sand materials should be good if you happen to have a soil very low in sand and high in clay and silt. It's a way to make more of a loam type soil. Okay, so next question would be, how do you know what to add to your soil? And so these are 6 questions I encourage you to ask yourself before you add fertilizer. First, you're going to know which elements do you need to add. And basically, you need to have a soil test or you won't be able to answer that question. Second, how much do I apply? And third, what type of material do I use? These are 3 questions I'm going to attempt to answer in the rest of my talk today. Other questions you should ask yourself, which I won't have time to get into, would be which application method is best? When's the best time to apply it? And will I get a return on my investment, either dollar-wise or maybe environmental-wise? So soil tests are very helpful in identifying either a nutrient deficiency or an imbalance or maybe a toxicity. Soil tests allow you to calculate fertilizer rates, and you can increase your yield and or save on fertilizer costs while decreasing environmental risks. I recommend doing soil tests in early spring, but not when soil is wet. So perhaps here in the Gallatin Valley, that means maybe best done in late fall. I get a lot of questions about, can I use home test kits, which are generally available at garden stores and also online. So this is a little review of soil laboratory versus home test kit. Test kits often will run N, P, and K plus pH. They have a huge range in cost, ranging from as low as about $15 to as high as about $750. And then there's a cost per sample because there's chemicals included in these kits that you can only use once per sample. Laboratories can do quite a bit more: NPK, pH salts, organic matter, micronutrients. They generally will run somewhere about $17 per sample for these 5 elements right here, plus some shipping cost. One thing to keep in mind, if you buy a test kit this year, it might not work for you in, say, 2 or 3 years because those reagents go bad. Also, you need to keep in mind what test method is being used. In Montana, I recommend a test called the Olsen test, which works better in high pH soils rather than the Bray test. Another difference between soil test kits and lab is that labs will almost always give you a number, an actual concentration, whereas a lot of home test kits will give you a rating like low, medium, high, sufficient, deficient. In one study that I found in a magazine where they evaluated 4 different home test kits, one of the test kits provided results close to the lab analysis. That happened to be the most expensive test kit. The other results were either moderately to far off. So my recommendation is to be careful if you do use a home test kit. And one thing you might want to do is actually do your own little study. Send some soils off to a laboratory and see what your home test kit results are and compare those to the lab results. So next question, how much to add? These are usually provided by laboratories on their soil test results. Some labs are a little more focused on ag crops, others a little more focused on gardens. I would recommend finding those garden labs, and I have a extension document that focuses on those garden labs. You will sometimes need to estimate how much to apply based on your garden area, what your crop needs are, and your soil test results. Usually those labs that have a garden component will give you recommendations in pounds per 1,000 square feet. Sometimes if you're using more of like an ag lab, they might provide them in pounds per acre, and then you'll have to look up how many square feet are in an acre. And I list a bunch of MSU pubs at the end that will provide example calculations and some fertilizer guidelines. But let me just show you a few examples from those documents. So this is what a soil test report might look like for nitrogen and organic matter. So usually they might provide the type that you've provided. You've told them that you're growing a garden. They might give you the nitrogen concentration in parts per million and then do a conversion over to pounds per acre. And usually for gardens, I recommend sending in a 6-inch sample. And this shows a pretty good organic matter, 4.3%. Some labs don't do that conversion for you. They might only provide the ppm or parts per million. Well, fortunately, the calculation or the conversion is very simple. If you get only the parts per million, just multiply that by 2, and that will tell you how much the amount of nitrogen is in pounds per acre, as long as you've collected a 6-inch sample. You also are going to need to use your percent organic matter to calculate your nitrogen needs. So this is a table from one of the Mont guides I was mentioning that focuses on the home garden. Note over here on the first column is nitrate expressed as nitrogen in pounds per acre. So we can look up here, see 20 pounds per acre. We're in the soil test report, and we know we're in this row. Then we can come over here to organic matter, and we have more than 3%. So that means we're going to be in this column. This column, this row, tells us this is how much nitrogen per 1,000 square feet that you need to add. What about phosphorus and potassium? So again, I mentioned that there's a couple different ways, actually a few different ways to measure plant available phosphorus. One is called the Bray, another's a Malick, and then there's the Olsen test, which I recommend for Montana. Potassium, there's pretty much one standard method, and then pH is also something good to have analyzed. So Bray works better in lower pH soils, somewhere less than 7. Olsen seems to work best above pH 6, and this test called the Malick 3 works for a wide range of pHs. So which p-test should be used in this soil? Well, it looks like probably either the Olsen test or the Malick 3, But MSU fertilizer guidelines are all based on the Olsen test. So that's what I would recommend. So once you know your Olsen phosphorus level of 107 parts per million, you can come down to this table, which again is in this Mont Guide or this soil scoop that I'll show you the link to at the end of this talk. You come way over here, Olsen P is greater than 16. In fact, it's way greater than 16. So I would probably not add any phosphorus. Maybe if I was 16 to maybe 30, I might add 1 pound per acre. For potassium, well, let me go back. For potassium, we have 400 parts per million. That's greater than 250, so you wouldn't need to add any potassium to this soil. What about micronutrients? I find in Montana, micronutrients are rarely lacking. Probably the main exception of that would be iron on trees, sometimes on raspberries, sometimes on strawberries. Make sure if you are going to add micronutrients, you read the label, make sure there's enough there to actually help you, and find out what form the micronutrient is. There's some that are less available than others. Any questions so far?
I see one in here from Cheryl. She had written that for fall leaves, I understand cottonwood leaves can be allelopathic. Does that substance go away with composting or when it's applied in fall?
You know, I don't know, and I hadn't heard that about cottonwood leaves. So the term allelopathic means that there's something in that product, whether it's a residue or leaves, that might impact growth if you apply too much of it. So I hadn't heard that with cottonwood. A lot of times these chemicals will break down with time, and I don't know specifically on cottonwood leaves. All right, I'm going to keep moving forward on to other factors that influence soil nutrient management. So what else should you look for on a soil test report besides N, P, and K? There's a lot of factors that affect plant health and production besides just those three nutrients. So when you get a soil test report back, make sure you look at soil organic matter. If you have less than 1%, which is almost unheard of for a garden, it means you really need to probably increase your nitrogen, maybe add some legumes, maybe add some manure compost. If you have greater than 3%, you're probably doing pretty good. That will supply a little bit extra nitrogen than if you have less than 3%. Soil pH, if you have less than 5, again, very rare for a home garden. You're probably going to get poor seedling establishment. Less than 6, you're probably not going to get good nodulation on your legumes like your peas. And if you have greater than 8.3, that's going to tie up some nutrients and usually is an indication you have too much sodium in your soil. Another thing to look for is soluble salts. Sometimes it's called salt index salts, sometimes EC, which stands for electrical conductivity, which is how salts are estimated. You want to make sure you don't have more than 4 because that means that you have a saline soil. You're probably going to see some wilt. When a soil is saline, it's hard for the plant to take up the water. And then also you might ask for texture or cation exchange capacity. Both of those will help hold nutrients and hold water. So just kind of looking at a real report from the Gallatin Valley. This is what a report might look like. If you have a small screen, this is probably hard to see, but essentially each of the parameters that the gardener asked for are listed here. So organic matter, nitrogen, phosphorus, potassium, and then a lot of labs will do this bar strategy, which kind of lets you quickly see what you're low in and what you're high in. So this soil, for example, is pretty high in phosphorus. It's low in sodium, which is actually a good thing, maybe a little low in iron, and most of the others are essentially in that kind of medium range. Let's walk through some of the more important ones there. So soil organic matter, 3.6%, as I mentioned, 5 would be probably a little better. You don't need probably more than about 8%. Cation exchange capacity, which I'll explain here briefly. It's the ability of a soil to hold nutrients. And this particular soil has about 24. That's pretty good. You don't want to see less than about 10 or so. That probably means you have a pretty sandy soil. It's going to be hard to hold nutrients. And then a pretty typical pH for Gallatin Valley, somewhere in the mid 7s. Not too high, not too low. Texture is generally the most expensive test at a laboratory. It takes them quite a while to analyze texture. So if you just want to do it yourself, you can go to this link or you can do a Google search on a mason jar texture test. And I've done one here for another workshop that I gave where you add soil, you add water, and then you add some dishwasher detergent, you shake it, and then you watch how fast things settle. The sand settles in about a minute, silt takes a few hours, and then clay generally takes overnight. So that's kind of a fun thing you can do yourself. Let me know if you have any questions on the mason jar texture test. As you probably know, as soils become more coarse, as they go from clay to silt to sand, your water and nutrient holding capacity will generally go down. Sand, of course, has larger pore space, low surface area, and that's why it can't hold nutrients. Clay is going to have much smaller pores. It's going to have much higher surface area, so the ability to hold more nutrients. Ideal would be somewhere between a loam to a clay loam, which we have quite a few of in the Gallatin Valley. Another way to think about this is sand, silt, and clay have different abilities for drainage, with excellent drainage for sand, poor for clay. Poor water holding capacity for sand, excellent for clay. Great aeration for sand, poor for clay, and then low cation exchange capacity for sand and high for clay. So there's good and bad for each, and that's why I like to see a blend of all three. So this kind of shows a representation, a graphical representation of what I was just talking about. So sand has big pore spaces and it's going to drain more freely. A clay loam has tiny pore spaces. It's not going to drain very well. Silt loam's pretty nice soil to work with. It's going to be kind of intermediate. Some problems in clay soils, even though they hold more water and they hold more nutrients, is they can pond and therefore run off if you water too much. They can compact and they can basically drown your roots because they don't drain enough. And that's why having some sand in a soil is actually a good thing. Any questions? And I did see there was one question about I've heard manure can be too hot. So what that means is if it's too fresh, especially something like, say, chicken manure, it will have too much of a nitrogen form called ammonia, which you've heard of. It smells bad. Probably most of you know the smell of ammonia because it's in a lot of cleaning products. That ammonia can be toxic to seeds and seedlings. So if it smells strongly of ammonia, I would let it sit for weeks to a month until that strong ammonia smell goes away. Other questions? All right, if you're typing right now, just feel free to keep typing, and I'm almost done the talk, and we'll get to your questions at the end. So on to my last two topics, pH and cation exchange capacity. Less than pH about 6, I would call acidic. Greater than about 8, I call basic. Somewhere in between is neutral. Most soils in the Gallatin Valley are going to be in the 6 to 8 range. And vegetables vary in the preferred soil pH. So do fruits. Blueberries like low pH. Other vegetables prefer higher pH. Legumes pretty much won't fix any of their own nitrogen if the pH is below 6. This is a schematic that shows the effect of increasing pH from 4 to 9 on nutrient availability. So a wide bar means that the nutrient is highly available at that pH. So nitrogen is highly available around pH 6.5 to 7. Phosphorus is pretty available around 6.5, but pretty low at 8. Potassium, again, pretty good, somewhere in the mid 6s. Some of these micronutrients, like let's say copper, or iron, or zinc, they tend to be quite available at low pH, but not as available at high pH. So here in the valley, we frequently see iron deficiency, for example, in aspen and raspberries and strawberries because there's so little iron available up in the 7s. At low pH, again, not so common here. This is going to provide a lot of micronutrients. It's going to be possibly low in phosphorus, low in nitrogen, and low in potassium. High pH, we kind of run into similar problems, low in N, P, and K, plenty of calcium, magnesium, low in some of these micronutrients. So if you have a high pH soil, what do you think is the best option to lower pH in highly calcareous soils, meaning with a lot of limestone? Is it best to add elemental sulfur, add some gypsum, add pine needles? Is there really no good way to do this? Maybe add nitrogen fertilizers or plant legumes. So think about that for a couple seconds. And I would argue there's really no reasonable option to significantly lower pH both quickly and on a fairly large scale. Elemental sulfur of probably all of these options will lower the pH the most, but as I'll show, it takes quite a bit to do that. This is a study conducted by AgVi's lab in North Dakota where they applied no sulfur, 23 pounds of sulfur, or 230 pounds of sulfur to a 1,000 square foot area. The initial pH at the beginning of this study in April was around 8. 5 months later, when they added no sulfur, it had changed a tiny bit. This is probably just variation. Adding a moderate level of sulfur dropped the pH a little bit more, and then adding 230 pounds dropped it to about 7.5. So the problem I see is the pH is still high and you've had to add quite a bit of product. So what are the consequences? And what are some of the costs of adding that elemental sulfur? Meaning what might happen if you add 230 pounds of sulfur? Well, soil sulfate levels may become toxic. This is what a leaf looks like that's had too much sulfate in the soil. Salt levels themselves may become toxic, and you'll end up spending about $366 per 1,000 square feet. And if you do this, say, over an acre, you're going to spend in the thousands of dollars. So maybe the best thing to do is just select plants that are suitable to your soil's pH. Grow blueberries if you have a low pH, maybe grow sweet peas if you have a high pH. Most vegetables do pretty well in the 7s. So a little bit on cation exchange capacity. This is essentially what we call the parking spaces for nutrients in the soil. And cations are positively charged nutrients. Remember that phrase, opposites attract. So that positively charged nutrients like potassium, zinc, ammonium will stick to these negative charges on the soil surface. So if a soil has a really high cation exchange capacity, it can hold a lot of positively charged nutrients. A clay has somewhat less than this really rich soil organic matter, but it can still hold a lot of nutrients. And then a loamy sand, notice it can hold very few nutrients. So soils with large surface areas like clay and soil organic matter are generally considered more fertile because they hold more nutrients and they have a higher CEC. One risk of high C soils is they will hold onto herbicides generally longer than low CEC soils. It is very hard to change the cation exchange capacity of a soil, but by slowly increasing soil organic matter, you can bump up the cation exchange capacity over time. So what management is influenced by cation exchange capacity and texture? Well, certainly your water management is going to be affected. If you have low CEC soils, this means you probably have sandier soils. You're going to need more short, frequent irrigations to avoid leaching your nutrients. On the other end of the scale, if you have high CEC soils, these tend to be the clays. There you're going to want to do more deep watering infrequently to avoid ponding. A low CEC soil, similar to a low CEC soil for water management, you're going to want to add a little bit of a time to avoid leaching. Again, a low CEC soil has low surface area, probably more of a sand. A high CEC soil, you're going to want to incorporate those nutrients to avoid them running off and to make sure that those nutrients get to your plant roots. So just to sum up what I've covered today, understanding soils leads to wise nutrient use and will help maximize your plant health and your vegetable yields. Soil testing is super critical. If you don't know what's in your soil, it's hard to know what to add. I feel the foundation of a healthy garden is a healthy soil. And even though I have a lot of documents out there that look fairly prescriptive, add this amount for this soil test, you really have to observe and adjust to your specific conditions. Look for nutrient deficiencies, toxicities. You know your soil better than, say, I do, and that will help. So for additional information, I have a whole bunch on home gardening at this web page here, landresources.montana.edu/soil fertility, and then you can click on home gardening. I didn't cover nutrient deficiency symptoms today, but I feel they're really important in a garden situation. And so I have a whole bunch of nutrient deficiency photos to help you identify what might be deficient. I have 2 soil scoops on home gardening that you can find at this address. And then for just more general extension documents, you can go to MSU's extension publication store, and there's things on manure, home composting, manure composting there. And with that, I will take any questions.
All right, well, thanks so much, Clain. It looks like we got a few in the chat bar here. Let me scroll through. So from Jennifer, is there a way to tell when you've applied enough sand to your clay soil so that it will drain well? I have heavy clay and have lost plants due to them sitting in water.
Yeah, unfortunately, it's a little bit trial and error. There's no magical prescription, but if it's really clay, I would consider adding, about maybe something like 2 inches of sand and mixing that well in the top 6 inches. So basically, I'm recommending about 1/3 by volume. You can overdo it too. You end up diluting maybe a fairly nutrient-rich or high organic matter soil. So yeah, I would add a little bit at a time. Maybe start with 1 or 2 inches, mix it in, water it, and see how it holds water and also how it drains.
Is there a risk in that when it comes to amending with sand. I've heard this before, that if you don't add enough, you could actually be making your situation worse. That if you under add sand.
Yeah, I've heard, people say, well, concrete, for example, is a mix of sand and clay, and so aren't you just making concrete? But if you look at the ingredients in concrete, it is very heavy lime. It's much more lime than we typically have in our soil. So I I don't quite buy that, and I feel like the more sand you have, the more potential for drainage. But again, it might be trial and error. Maybe you'll add some and it won't have much of an effect, and then you'll have to add more.
And then, let's see. Jamie sent one. Did you see that about the manure?
I only see her what kind of sand. Oh, yeah, I answered that one.
Yep, okay. The manure to be too hot. And then, where do we send our soil tests? Or yeah.
Yeah, and so at this link here, the home gardening link, there's a Mont guide that, so the second bullet down on that home gardening page is a guide, and on the very last page there's a list of regional labs, and so you can call those up, you can email them, and then those would be where you would send the samples to. We also have indicated the ones that focus a little more on the home garden versus agriculture at that particular link.
Okay.
So I'm just gonna quickly take people there. So this is what my page looks like. Come over here on the left, you click on home garden. Second bullet down is this document called Home Garden Soil Testing and Fertilizer Guidelines. You click on that PDF. There's some tips there on soil sampling, soil testing, what type of equipment you might
need. We're still looking at your PowerPoint.
Okay, right.
So I wonder if you can change. Perfect. There we are. Great.
So you're seeing
your web browser. Yep.
So are you seeing Soil Fertility Extension Program now?
Yep. Yep.
Great. So yeah, home gardening. Second bullet is this Mont guide called Home Garden Soil Testing and Fertilizer Guidelines. You're seeing that? Emily, are you seeing Home Garden Soil Testing and Fertilizer Guidelines? I see a thumbs up from Cheryl. Thank you.
Mont guide.
Yep. And then there's different symptoms to look for here. There's what a typical test report looks like. Some of those tables like I was showing you in the talk. And then on the very last page, hopefully I'm not giving anyone a headache, there's a list of regional laboratories that you can email or call. And then when you get your results back, if they still don't mean much to you, just email me the results and we can talk them over.
All right, great.
I have a question.
Go ahead.
Okay, I've got a garden that has been overtaken by rhizomatous rooted grasses, and I want to be able to plant this year without my garden crop getting completely shaded out like last year. And do you have any solutions other than using herbicide? Because I'm concerned about how soon I can replant if I do use chemical to get rid of this major problem.
Yeah, I mean that's a major problem. I'm not much of a herbicide person, but digging, it's very laborious. But digging and then putting down some sort of vertical piece of metal, something to prevent those rhizomatous grasses from uh, coming back in. Emily or Cheryl, do you have any advice on getting rid of grasses in a garden?
This is Cheryl. And if you're not adverse to using glyphosate, it is labeled for use in vegetable gardens. So that would be an option. I would get on their website and look at the specific timing. The Pacific Northwest has a good publication that talks about the different timing in a vegetable garden.
Thanks,
Yeah,
Cheryl.
I would
Thanks.
second that. There's a couple, everything that's available as far as products and stuff go, they're just different tools. And they're used for different things, and wielded appropriately, you can expect different results. So, hand digging, that if you're averse to using any type of herbicide product, again, using a physical barrier, like Clain recommended, as well as then, manually removing it, can certainly help you with that. But again, they're all different tools. And if you look at things like IPM, you want to start with the tool that is the lightest duty, if you will, and then from there move up to bigger guns if you have to. But the IPM takes into consideration a lot of things like, what is the threshold for your garden for dealing with different things. So again, if you stop in the store or questions like that, we'd be happy to field them because they are all individual kind of situations. So, and then Cheryl, you had another question about the rototilling. Do you want to ask that?
Oh, yeah. Okay. So a lot of people like to rototill their gardens every year. And I'm wondering if that, in your opinion, destroys the tilth, if it's a good thing or not. And that's typically in ground gardens. And then there are people who like to use broad forks in their raised beds every year just to help aerate the situation. Can you give your opinion on those processes?
Yeah, so something I didn't really mention today is soils have a property called structure. And so structure could be anything from, large pieces of soil to what's called columns of soil. What we really like to see is aggregates of soil. So that means chunks of soil that allow roots, water, air and nutrients to pass through them. If you rototill every year, those bigger aggregates will eventually get broken down till you have small aggregates or no aggregates. So yes, rototilling is not great for soil structure, and I realize that if you have a large garden, a bad back like many of us do, that shoveling might not be the greatest option. But I think there's ways to, with some light hoeing, basically you can build a seed bed and not destroy your structure. The second, the aeration equipment that you mentioned, I'm not as familiar with. Certainly some aeration is good, but I don't know that particular tool. Any other questions?
So I had one. When you get a soil test done, it does profile, for example, iron. I've heard that in some places there's plenty of iron in the soil, but it's not accessible because of the pH. When you get a soil test done, does it tell you what's there as well as how to interpret that as, is it, even if it's there, is it accessible?
Yeah, so So soil tests have been developed over decades to centuries to try to best estimate in the laboratory what the plant can see, what's available to the plant. So when you get, say, an iron test back and it says 100 parts per million, and we know, say, the sufficiency level is, say, above 50 parts per million, just as an example, that's how much is plant available. If the lab had analyzed what's called total iron, all the iron in the soil, it might find that you have something like 10,000 parts per million. But most of that iron is tied up in minerals. So that is irrelevant. And that's why the labs just analyze plant available based on selecting reagents that best imitate what's happening in the soil. So it's plant available is what you get when you ask for P, phosphorus, potassium, zinc, or iron, for example.
Thanks for answering that. Yeah, and then as far as frequency of testing, I think, if you're new to gardening and you're starting a new bed, I said like one of the best things you can do before you start adding anything or altering anything or amending anything is get a soil test done, and then go from there. Beyond that, how often would you recommend a home vegetable gardener having, repeating a test?
Yeah, good question. In agriculture, we highly recommend every year, but there's some, giant economic implications to not doing that. Because if you over apply nitrogen or under apply nitrogen, that could put you in the red. In a home garden, that's less of a concern. So I would probably recommend maybe every 5 years after that initial testing, to have it done again. What typically home gardeners do is they don't do any soil testing until there's a problem. And then what that problem often is maybe too much nutrients. And then it's kind of too late. So I think I would recommend when you build that bed, and then about every 5 years. And that, if you keep good records, that will allow you to look for trends. Am I accumulating too much phosphorus or too much potassium? Or maybe I'm depleting one of those two. So I'd say every 5 years is probably good.
Okay. So one other thing that came up was the, so OM, organic material. So for example, Cashman sells a 50-50 blend that people use as their first thing in their to fill a raised garden bed, and it's 50% screen topsoil and it's 50% compost. And when you were talking about the different organic material levels, what stood out to me is that, so that mix in particular, right, is 50% compost, but that doesn't mean that mix is 50% organic material. So can you just say a little bit about how to look at, percent organic material in your, ideal in your soil versus, percent of an amendment?
Sure. Yeah. So a lot of times amendments don't list the percent organic matter, and you might have to have it analyzed. When I've analyzed like manure, compost, in my head, I kind of would guess that they'd be 100% organic matter, but they're never close to 100% organic matter. And I think that's because, like, if you think how manure is collected, say in a feedlot, a lot of times you scrape up a lot of soil and there's manure in there. Or, for example, some animals actually eat some soil when they're trying to graze. And so what I've found is, or manure composts are closer to somewhere between like 20 to 50% organic matter. So in your product that's 50-50, let's just assume that manure compost is 50% organic matter. That means now you're down to 25% organic matter in that material, and maybe even less. So that's where you as Cashmans could actually analyze that product to be information for your gardeners. Or if you don't do that, then the gardener would have to analyze that themselves.
Yeah, because based on some of the charts and stuff and recommendations, it would seem to me that 50% organic matter would actually be pretty high, a lot higher than what's recommended.
Yeah, and I think if you analyze that, it probably won't be close to 50%. There's probably soil in that manure compost, and there might be a fair amount of it. So I would think that would be pretty rich. A product like that is probably great to work with. It's dark, it looks beautiful, but it's likely more than is needed.
Yeah, so oversaturating with nutrients.
So maybe you buy that 1-to-1 product and you mix it in another 2 to 4 inches of soil, and now you probably have, more like maybe 10 or 12% organic matter, which is a great, garden organic matter.
Perfect. Okay. And then we've got another one from HP. What soil should be put in a large flower pot?
In a flower pot, compared to a garden, one thing you want is good drainage. And so there I would recommend more of a potting soil. If you do regular soil in a pot, it's going to compact and compress and probably not drain very well. So in a pot, I would generally go with almost straight potting soil.
All right. Are there any more questions?
I do have one quick question. What if I was gonna try something out where I bought a fig plant that I can keep on my deck during the summer and then bring in during the winter. Is that a tree? Since it's more like a tree, would potting soil still be appropriate for that, or does it depend what you're putting in the pot as well? I guess is my question.
Yeah, from my perspective, you said it was a fig tree?
Yeah, I'm just
Right.
kind of doing experimentation.
Yeah, so the downside of maybe straight potting soil is it might not have be dense enough to hold up a large tree. So I was thinking more talking about like annual flowers,
Mhm.
something that doesn't have a lot of weight. And so there maybe you might want to add potting soil, topsoil mix to give it a little more density to be able to hold up a tree, maybe like a 50-50 potting soil mix. Just a guess.
Cool. Thanks for your opinion.
Yep.
And I would say that, and this is addressing another question we just got. What should be bought for starting seeds? Is that a lot of potting mixes, germination mixes, which is what's used for germinating seeds. They're typically called soilless, and it's because they are just that. They're typically a very basic, a fine cut peat. Some fine vermiculite. If they have perlite, it's usually very, very small particle size. Sometimes there's some sand in it, but it typically does not have actually any soil in it. And outdoor potting mixes, they'll have compost in it, which would have some soil in it. So that's kind of an in between. And it has, better water retention and stuff for potted plants, because if you have a small pot, if it gets hot, it just doesn't hold moisture very well. Yeah, there's different kind of stages. So I think I would say too, for having something like a fig tree, you're going to need something with some support there to stay away from things that are totally soilless, or mix them with something that actually has soil in it. Versus HP's question here for starting seeds, you're good to go with using a soilless. That's probably the best because it's so nice and fluffy. All right. Any more questions this morning? Well, if you think of anything, feel free to send us an email or reach out to Clain. Clain, I want to thank you again. You know, the work that you do is so important to, you know, preserving the, you know, vast, you know, agricultural economy in our state. But I also really appreciate too your ability to distill down that stuff and for the everyday home gardener. And yeah, the soil scoops and stuff, I'll put links to those sites on our webpage so that everyone who's here can access them. But they're fantastic. And again, thanks so much for presenting. It's been a pleasure. Learned a lot.
No problem. Have a good weekend, everyone.
All right, take care.
Thank you.
Thank you, guys.
Bye.
Thank you.